So this is OCR's paper 2, the foundation paper. It's non-calculator from June 2018. And if we look at the grade boundaries, we need 32 marks for a 3, 45 marks for a 4, and 58 marks would get you a grade 5 on this paper. Question 1, we're looking for a multiple of 6 between 10 and 20. Well, your multiples of 6 is your 6 times table. 6, 12, 18, 24. Here is between 10 and 20. It's 18. Part B, we're looking for 2 factors of 30 that are prime numbers. Well, the factors of 30 are all the numbers that times together to make 30. So we've got 1 times 30. We've got 2 times 15. We've got 3 times 10. And we've also got 5 times 6. They are all the numbers that are factors of 30. We want 2 of them that are prime numbers. And prime numbers are numbers that will only divide exactly by themselves and 1. I know that 5 is a prime number. 5 will only divide exactly by itself and 1. I also know that 3 is a prime number. 3 divides by 3 exactly, and 3 divides by 1 exactly, and that's it. Question 2, we're looking to turn these fractions into decimals. Well, 9/10 is 9 divided by 10, which is 0.9. 3/4, again, that's 3 divided by 4. 3 divided by 4, 3/4 is 0.75. Part B says a plank of wood is 2.4 meters long and it's cut into 6 pieces of equal length. How long is each piece? In order to answer this, we need to do 2.4 divided by 6. How many 6s into this 2.4? If you can't do that, do 24 divided by 6. And 24 divided by 6, how many 6s in 24? 6, 12, 18, 24. That is 4. So 24 divided by 6 is 4, but I needed to do 2.4 divided by 6. So this needs to come down by a factor of 10. Because from 24 to 2.4 is 10 times less, this answer will be 10 times less. So 4 divided by 10 is 0.4. There's your answer, 0.4 meters. Question 3, I'm just looking to work out what 10 cubed is. Well, 10 cubed is 10 times 10 times 10. Be careful with this. 10 times 10 is 100. Times 10 again is 1,000. This is not 10, 20, 30. That's 100. Times 10 again would be 1,000. Part 2, we're looking to work out this calculation. Remember, whenever we're working out maths calculations, we need to follow BIDMAS, the order of operations we do in maths. This says brackets first, so I must work out these brackets first, but multiplication comes before addition and subtraction. So within the brackets, I must do the multiplication part first. So I'm going to do 3 times 2 is 6. Right, everything else down. I'm now going to do the brackets part. 8 take away 6 is 2. And what we're left with is a 9 on the outside of the bracket and a 2 inside of the bracket. This is just a multiplication. Whenever you've got brackets involved and no operators, you've got to do a multiplication. And 9 times 2 is 18. Part B, I'm looking to put brackets into this sum to make it correct. So I'm looking to put brackets around any part of this that then means when I work this side out, I get 17. We just got to try some guesses with this. So let's try putting brackets around those. Remember, brackets are done first. So if I put brackets there, 1 add 2 is 3. I'll do 3 times 3 is 9. And then 9 add 5 would be 14. Not 17. So that's not right. Let's start again. I might try putting some brackets around this part. And again, if I do brackets first, I can work this bit out first. And 3 add 5 is 8. I'm going to be left with 1 add 2 times 8. Following BIDMAS still, multiplication first. 2 times 8 is 16. And 1 add 16 is the 17 that I was looking for. So question 4, we've got a nice page of algebra to work through. First one is just simplifying an expression. You've got 5x, take away 1x. That would be 4x's. Then you've got negative 6y, add 3y. Start at negative 6 and add 3. You'll finish at negative 3y. Part 2, we're looking to simplify w to the 8 divided by w squared. Laws of indices, we just need to do 8 take 2, which is 6. Part 3, again, laws of indices, we're going to do 5 multiplied by 3, which is 15. We've got c squared times c, which is c cubed, and then there's just d tagging along on the end. Part B, we've got some substitution to do. So we've got an expression here, and we're told that x is 5. So 4x becomes 4 times 5, not 45. This is a multiplication. So 4x, 4 times 5, then take away 7. Well, 4 5s are 20, and 20 take 7 is 13. And then final part of this question, we've got another expression here, and we're told that p is 2. So we're going to do 2 added to 7, then divide by 3. 2 add 7 is 9, and 9 divided by 3 is 3. Question 5, we've got a shape drawn on a 1 centimetre grid, and we're asked for the mathematical name of this shape. Well, this shape is a rhombus. All these 4 sides are the same length, like a square, but it's been pushed over, so it's a tilted square called a rhombus. How many lines of symmetry does this shape have? Well, symmetry is mirror lines, or lines of symmetry are mirror lines. So there's 2 mirror lines there. This side perfectly matches this side. If you think that these might also be lines of symmetry, then that's incorrect, because this bottom side here would not fold over perfectly to match this side. They're the same area, but if you folded along this green mirror line, it wouldn't match perfectly on the other side. So that the answer is just the 2 red ones. Part C, we're asked to work out the area of the shape. So we want to know how many full squares it takes up. Well, there's 1, 2, 3, 4. And then what we've got is part squares. So we need to start piecing these together. And if we look at that one and that one, they would fit together to make a perfect square. So that's number 5. We can do the same down here. That would be number 6. Same on this side. 7 and 8. Then we need to find other part squares that add together to make a full one. Well, there's one. Combined with this, they would fit together to make a full square. So that's number 9. We've got the same down here. 10. And on this side, 11. And finally on this part of the shape here, 12. 12 full squares. The area is 12. Question 6, we've got a dual bar chart to work through. It's showing monthly expenditure. So what money we spent on bills, transport, housing. In 2005, the dark grey, and 2015, the light grey. What we're asked for, in which category was there a decrease in the average monthly spend between dark grey and light grey, 2005, 2015. So we're looking for, where is the second bar smaller than the first bar? Well, it's not here, not here, not here. There, look. that bar is lower than this bar, meaning the spending went down in 2015 compared to 2005. So it is entertainment. Part B, how much more was the average monthly expenditure on housing in 2015 than in 25? So we're looking for housing, which is here. We need the 2015 and 2005 figures. So let's look at 2005 first. We need that one. Now be careful, it's not going up in tens, 10, 20, 30, 40, 50. It might be 20s, 420, 40, 60, 80, yeah, 500. So that there is £480. We also need this figure here, the 2015 amount. Well, again, going up in 20s, 520, 40, 60. So we've got 560. And what we're looking for is the difference between those, how much more this is than this. How do you get from 480 to 60? We'll add 20, it'll get me to 500, and then add another 60. That's a difference of £80. We're told that the total monthly spending in 2005 was 1,200. So all of these grey bars add up to 1,200. That's everything in 2005. And we want to know what percentage was spent on transport. So if we find the transport, well, transport is here. Again, remembering we're counting in 20s, we've got 220, 40. That's £240. The total is 1,200. So we're going to first write this as a fraction. We're saying that it's 240 out of 1,200. And then we're going to try and turn this into a percentage. Well, straight away, that's 24 out of 120. Just knocking a zero, dividing top and bottom by 10. If we divide both of these by 12, then 24 divided by 12 is 2. And 120 divided by 12 is 10. 10 times 12 is 120. Why am I doing this? Well, what I'm looking for is out of 100. And when I get down to 10 on the bottom, I can quickly get up to 100 just by timesing by 10. 10 times 10 is 100. So I'm going to do 2 times 10, which is 20. And 20 out of 100 is 20%. Question 7, we've got a triangle, we've got some parallel lines, and we're looking for the angle BDC. Well, from B to D to C is that angle there, so that's the angle we want in the end. Usually we'll have to find other angles first. So what I'm going to do is work on this triangle first. And if I add these two angles together, 80, add 56, comes to 8 add 5 is 13, 136. We know that angles in a triangle add to 180. So I'm going to do 180, take away 136. Need to borrow from the 8. 10 take 6 is 4. 7 take 3 is 4. And 1 take 1 is 0. This angle here is 44. We do need a reason for each angle we find. So the reason that this is 44 is angles in a triangle add to 180 degrees. What we can look at now is this parallel line going up here and meeting this parallel line. And what we've got is a set of co-interior angles. So the angle that I'm looking for is also 44 degrees. So I'm just going to write that down. And the reason is alternate angles are equal. Question 8, we've got Liam is 0.83 meters tall. And we've got William is 1.31 meters tall. And then we've got some information about Jacob, but I'm going to ignore that for now because we talk here about the difference between Liam and William's height. So I'm going to work on that bit first. We're going to look at the difference between the two heights. Well, if William is 1.31 and Liam is 0.83, and I want the difference, then I'm going to do subtraction. Now, we can't do 1 take 3, we can't do 3 take 8, so we're going to borrow from here and change that to a 13. Then we're going to borrow from here and change that to a 12. I'm going to do 11 take 3, which is 8. 12 take 8 is 4. And then 0 take 0 is 0. So what we've got here is the difference between Liam's height and William's height. If we go back to this third line and look at what we're saying about Jacob, it says Jacob is taller than Liam by half of this difference. So what I need to do is half this 0.48. Well, 48 halved is 24, so 0.48 halved would be 0.24. Back to Jacob then. It says he's taller than Liam by this amount. So we need to go back into Liam's height. Liam is 0.83. And we're going to add on this 0.24 that we've just worked out. And it's just an addition. 3 add 4 is 7. 8 add 2 is 10. Decimal point, decimal point, decimal point. And that would just be 1.07. My friend Jacob is 1.07 meters tall. Question 9, we've got someone dividing some money between Hannah and Adele, and it's in the ratio 2:3. So I'm just going to quickly sketch that out. We've got 2 parts for Hannah, and we've got 3 parts for Adele. So Adele gets 3 parts. Elise is saying that Hannah gets 2/3 of the money. Well, Hannah gets 2 parts out of, not 3 parts, out of 5 altogether. There is 5 parts in this diagram. So Hannah gets 2/5, not 2/3. We've got a similar question down here, just in reverse. We've got George with some different money, and he's dividing it between 2 people. One person gets 11/17. We need the ratio that they share that money into. So let's have a look. If we've got Siobhan and Ewan gets 11/17. Well, Siobhan must get everything else, so that would be 6/17. We know that this person gets 6 parts of the ratio, and this person gets 11 parts of the ratio. My ratio is 6:11. Question 10, we've got a Venn diagram showing students in year 10 who study history and geography. And we're told that there are 29 students in the tutor group. How many students in the tutor group do not study history or geography? So I'm looking for these people outside that don't study any of these subjects. Well, what we've got to do is remember that these all add up to 29. So I'm going to do 13 added to 5 added to 9. 13 add 5 is 18. 18 add 9 is 27. And if there are 29 students altogether, then how do we get from 27 to 29? It must be 2 more students. Part 2 says how many students in the group study history? Well, history is all of these people, including the people in the middle. So we need to do 13 added to 5, which is 18. Part 3 says one of the 29 students is selected at random. What's the probability that they study geography but not history. So geography but not history. Well, this circle is geography. Those people in the middle study history as well. So I don't want those. I just want these 9 students, geography but not history. So that would be 9 people out of everybody, 29. And then part B of this question, we've got another Venn diagram, but this time it's about art and physics. You can see the 2 separate circles. How many students study both art and physics? That is 0. Question 11, we've got a bag containing red grapes and green grapes, and we know that 4/9 of the grapes are red, and we also know that there are 8 red grapes. So 4/9 of the grapes are red, and that is the same as 8 out of the total grapes. We know 4/9 are red. We know there are 8 out of total. What we've got here is equivalent fractions. To get from 4 to 8, we're timesing by 2. If we times the bottom by 2, 9 times 2 is 18. Altogether, there are 18 grapes. Be careful. The question says how many green grapes. Well, if we know there are 8 red and 18 in total, then 18 take away 8 is 10. Part B, we've got a different bag, still red and green grapes. It says the number of grapes is different, so it's different to above, but we've still got 4/9 red. Sophia then picks out a red grape, and now we've got 3/7 red. And what we want to know is how many of each grape in the bag. Well, what's happened is we've gone 4/9 red to 3/7 red. And if we can work out the difference between those fractions, then we know that that difference is the 1 red grape that she ate. So I'm going to write that down. 4/9 is my starting fraction. Take away 3/7, just working out the difference between the two. If we're going to subtract fractions, we need common denominators. So multiply 9 by 7, you get 63. We multiplied by the 9 by 7, so I'm going to multiply the 4 by 7, and 4 7s are 28. I multiplied the 7 by 9, so I'm going to multiply the 3 by 9, and that would be 27. Now we're going to do 28 63rds, take away 27 63rds, which is 1 63rd. That 1 63rd is the 1 grape that Sophia ate. So if 1 grape is 1 63rd, then there are 63 grapes in the bag. The question actually says how many of the remaining grapes in her bag are red and how many are green. So we're going to use this idea that there are 63 grapes in the bag. When we started the question, we worked with 3/7, and 3/7 is the same as 27 63rds. This is actually the red grapes at the end of the question. So red is 27 grapes. Should have done that in a different colour. Can we work out how many green in the bag at the end? Well, if 27 out of 63 are green, we need to do 63, take away 27, and 63 take away 27 is 36. Question 12, we've got some more algebra to do. This first part says multiply out, so we're going to multiply 4c by d. And 4c times d is 4cd. Then we're going to multiply 4c times -5. Well, 4 times -5 is -20, but we had 4c there, so it's going to be -20c. Part B, we've got a double bracket to expand, so I'll use a grid for this. You might not use grid, you might use this kind of idea. But we've got 3x plus 2, and then we've got x and -4, And we're just going to take this bit by bit. X times 3x is 3x squared. X times 2 is 2x. Negative 4 times 3x, well, negative 4 times 3 is negative 12. So this would be negative 12x. And negative 4 times 2 is negative 8. These two terms will always simplify. So negative 12x add 2x, negative 12 add 2 is negative 10x. And then we've still got the 3x squared. And we've still got the negative 8. Part C, solving an inequality. Well, this is just like solving an equation. So we've got 3x minus 2. Some people say change that to an equal sign, but I'm not going to bother because I'll forget to change it back. All we're going to do is add 2 to both sides. And we've got 3x. Keep your inequality symbol. 22 add 2 is 24. And then divide both sides by 3. And you've got x is less than or equal to 24 divided by 3. 8, 16, 24. The answer is 8. Question 13, we've got two fractions to add together. So I'm going to do 3/5 added to 5/8. If we're adding fractions, we need common denominators. And we get common denominators by multiplying these together. 5 times 8 is 40. So I'm going to work in 40ths. I multiplied the 5 by 8, so multiply the 3 by 8. 8, 16, 24. I multiplied the 8 by 5, so I'm going to multiply the 5 by 5. And 5 5s are 25. Now I'm going to add these two fractions together. 24 40ths add 25 40th is still 40ths. And 24 add 25 would be 49. It does say give my answer as a mixed number in simplest form. Well, 40 of these 49 40ths, 40 40ths makes the whole 1. And then there's 9 40ths left. And that is my final answer. I cannot divide top and bottom by 2 to simplify because I'll get a decimal. I could divide this by 3, but 40 will not divide by 3 exactly. So that's my final answer. Part B, we've got some standard form numbers and we're asked to subtract them. So what I'm going to do is write these as normal numbers. 5 times 10 to the 4 is 5 times 10 once, twice, 3 times, 4 times. And 1.6 times 10 to the 3, well, that's times 10 once, that's times 10 twice, and that's times 10 a third time, sorry. And I'm going to subtract these from each other. 5, no, 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 take away 1, 6, no, no. Note take note is no. Note take note is note. Can't do note take 6 and can't borrow from here. So I'm going to borrow from the 5 and put a 4. And then I'm going to borrow from this 10 and put a 9. And we get 10 take 6 is 4. 9 take 1 is 8. And 4 take 0 is 4. This is the answer to the calculation, 48400. But it says, give your answer in standard form. So I need to convert this to standard form. I need all the digits, and this number has to be less than 10. So I'm going to put a decimal point in somewhere here. 4.8400. That is now less than 10. And how do I get this number back to that one? I'm going to times it by 10 once, twice, 3 times, 4 times. So what we've got is 4.84 times 10, 4 times. Question 14, we've got some information about 110 grams of cereal. So how many grams of carbs, protein and fats? And someone is saying more than 90% is carbohydrates. And we're asked to find if she's correct or not. So I think what we're being asked to do is find out 90% of the 110 grams. And then we're going to compare it to this figure. So we can start by working out 10%. And 10%, well, 10% of any number is just that number divided by 10. So 10% of 110, which is 11. When we've got 10%, we can work out 90% just by multiplying by 9. And 11 times 9 is 99. So 90 grams is 90%. Emily says more than 90% is carbohydrates. Is she right? Well, 90% is 99 grams. Carbohydrates is 99.4 grams. Yes, she is correct. This is more than this. And we just need to say that 99.4 is more than 99. Question 15 is a bit of a brute. We've got a rectangular room. The floor plan is there. And we're going to put carpet tiles on this. And then there's loads of information about what's going to happen and how many tiles we need and what it's going to cost. I'm just going to work through all of these bit by bit so we know exactly where we are. We can look at this floor plan, and the first line of this question says we're going to put tiles on it, and each tile is 50 centimetres by 50 centimetres. Now up here, I'm working in metres. So I'm going to convert these to centimetres just so they match my tiles that are going down on the floor. So to convert metres to centimetres, I just times 100. So 3 metres is 300 centimetres. Times 4.5 by 100, I get 450 centimetres. What we can do with this information is figure out how many tiles are going to fit on this floor plan. So if this length is 300 centimetres and each tile is 50 centimetres, I can figure out how many tiles fit across this diagram. And the way to do that mathematically is to say, well, I've got 300 centimetres and I'm going to divide by 50 centimetres. How many 50s go into 300? Well, that's the same as how many 5s go into 30. There will be 6 tiles fit downwards. I can do the same working across the diagram. Each tile is 50 centimetres. So I'm going to see how many 50s fit into this measurement. So I'm going to do 450 divided by 50. That's the same as 45 divided by 5. And 45 divided by 5 is 9. So there are 9 tiles fitting across the diagram. We can work out the total tiles. Well, if there are 6 along the side of the diagram and 9 across the top, there's going to be 9 lots of 6. 9 times 6 is 54 tiles. Let's go back to the question. It says the tiles are only sold in packs of 10. So I can't buy 54 tiles. I need to buy 60 tiles, which is 6 packs. Each pack costs £20. Well, I'm going to buy 6 packs, and each pack is £20. 6 lots of 20, 2, 4, 6, 8, 10, 12, £120. So this is what I'm going to pay for the tiles. It says Tim pays for a fitting rate of £7.50 per square metre with any fraction of a square rounded up. So now we want to work in square metres. We need to know how many square metres in this floor plan. So what I'm going to do is go back to my metres and do 3 multiplied by 4.5. You can keep adding 4.5s if you want. 4.5, add 4.5, add 4.5. Well, it'll be 4, 8, 12. And then I'm going to do 0.5, add 0.5, add 0.5. Well, 2 of those would be a whole 1. Add another 1 would be 1.5. And what we get is 13.5 square meters. Remember in the question it says any fraction of square meters rounded up, so this needs rounding up to 14 square meters. And then the final part says there's £7.50 for every square meter, so I need to do 14 lots of £7.50. And this is not as hard as it looks. If we break it down, we can do 7 times 14. Well, 7 times 10 is 70. Then I'm going to do 7 times 4, which is 28. So 7 times 14 is 7 tens added to 7 fours. And then I'm going to deal with this bit, which is 0.5 times 14. I'm going to do that all as one. 0.5 times 14 is a half of 14, which is 7. 70 add 28 is 98. Added to 7 is £105. This is what we pay for fitting. Down here is what we pay for tiles. Total cost is 105 added to 120, and that's going to be £225. So question 16 is absolutely disgusting. What we've got is 4 trapeziums placed on a coordinate grid as shown, and then we've got some coordinates. Well, I'm going to ignore the fact that these are coordinates for now and pretend that they're just side lengths, which they are really. If this point is at A, then that side length there is A long. And we can repeat that anywhere on this grid. That side length there matches, so that would be A long. And I can even say this one here is A. And there's another one there, look. That whole thing would also be A. We've got another side of our trapezium which goes up to B. So I'm going to say the same thing, but this side here is B long. And then I'm going to find anywhere else where I've got a B. That there, look, is a B. Here is a B. And I think there's another one up there, a B. I've just put the lengths of these trapeziums in place, just A's and B's. It then says write down an algebraic expression for the coordinates of P. So I'm looking for this point here. Well, the across coordinate is not too bad because I'm going to go across to A. So the x coordinate is just A, across to A. I need to find this measurement here, which is not a full A, and it's not a B. If the whole thing is A and this part is B, then this measurement must be A, take away B. Part B gives us the coordinate of point Q, which is up here, and it asks us to work out the value of A and B. So I need to figure out how I can get up to here along these measurements and then look at these numbers. Well, let's have a look at this x coordinate. I'm going to go across A, and then I'm going to go across another A, and that would get me in line with Q. So I know that A add A gets me to Q. So I've got 2 A's. That must be this 16 measurement. And if 2 A's is 16, then A must be 8. I now need to see how I get up to Q. I think I'm going to use this measurement that I worked out earlier. So I've got an A minus B. And then I'm going to do this measurement, which is another A. And that got me all the way up to Q. So there's an A minus B and an A. So let's sort this out. We've got 2 A's, take away B, and that must come to the 13 high that Q is. So that equals 13. Now I know that A is 8, so 2 A's will be 16. I'm still going to take away B, and that comes to 13. 16 take something is 13. That something must be 3. Question 17, we've got someone cycling from home to visit his aunt, and we've got a graph of that journey. And we're asked one assumption that Viraj made when he drew his graph. Well, we've got these perfect straight lines on a distance time graph. When you've got these perfect straight lines, it's saying whoever's cycling is going at a constant speed. These nice straight lines means we're always going at the same speed. Different speed, but same all the way along this line. For how long did Viraj stop at the shop? Well, the stop is here, where his distance stays the same. Okay, he must be stopped because along here is always 7 kilometers from home. So we need to read down to this time and down to this time. And I think each small box will be 1 minute. I'll just check. 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 40. Yep. So from 20 minutes to 32 minutes is 12 minutes. Part C, we're asked to work out the average speed between home and the shop. Well, we know that we stop at the shop. So we're working from home here up to the shop. And if we're looking at speed, we need to know the distance and the time, because speed is distance divided by time. So let's have a look at how far it is to the shop. The distance is 7 kilometers. And the time taken, let's work down to have a look at time, 20 minutes. So we've got the distance and the time, and we could work out the speed by doing 7 divided by 20. But the question says give your answers in meters per minute. And at the minute we've got kilometers. So what I'm going to do is change that to meters. There are 1,000 meters in every kilometer. And what we're left with is 7,000 meters divided by 20 minutes. Minutes is fine because we want meters per minute. How can we do 7,000 divided by 20? Well, that's the same as 700 divided by 2. And 700 divided by 2 is 350 meters per minute. Part D says, how can you tell without doing any calculations that the speed between home and the shop, so this bit, is faster than the speed between the shop and his aunt, so faster than this bit. And the reason being, we've got a steeper line or a steeper gradient. Question 5, we've got a table showing relative frequencies of results from a football team after a number of games, and it says complete the table. Well, when you've got relative frequencies, these boxes, these probabilities, which is what relative frequency is, needs to add up to the whole one. So 0.2 added to 0.45 is 0.65, and 1 take away 0.65 is this missing box here, and 1 take away 0.65 is 0.35. Part B says the team lost 10 more games than they won. So I'm looking at the difference between lost and won. So if we just look at these relative frequencies and say, okay, if I look at the difference between those, 0.45 take away 0.2 is, if I have to take note, it's 5, that would be 2, 0.25. That 0.25 represents 10 games, because that's the difference between how many they lost and how many they won in terms of relative frequencies. What we can do is use that to figure out how many games they played altogether. Well, if 0.25 represents 10 games, then I can multiply that by 4, and multiply that by 4. 0.25 times 4, a quarter times 4 is 1. That 1 is everything when it comes to probability or relative frequencies. So multiply this by 4. They played 40 games altogether. Question 19, we're looking at a car's dashboard and it's talking about how much fuel is left in the car. We also know how many miles have been travelled. So we started with a full tank and we're now down to this. So I'm going to write a fraction. This looks a bit like a fraction bar. A fraction for how much fuel has been used. So there's 1, 2, 3, 4, 5, 6, 7, 8 parts in this bar, and we've used 1, 2, 3 of them. So we know that 3/8, that's how much fuel has gone, and that must be worth 165 miles. If I can work out 1/8, then I can work out a full tank. So I'm going to do that now. Well, if 3/8 is 165 miles, then 1/8 must be 165 divided by 3. So I'm going to work that out now. How many 3's go into 165? 3's into 1 is 0. 3's into 16. Well, 3 6's are 18. 3 5's are 15. So it would be 5 remainder 1. And 3's into 15 is 3. So what this is saying is 1/8 of the tank is now 53 miles. If I know what 1/8 of the tank is, I can work out 8/8, which is a full tank. How do we do that? Well, I know that 1/8 is 53 miles. I want 8/8, so I'm going to do 53 multiplied by 8. 8 3's are 24. 8 5's are 40. Add on this 2 would be 42. The car will do 424 miles on a full tank. Part B says, what assumptions have you made when answering part A? And the big assumption here is that the car uses the same petrol all the time. So if this car is full of petrol, it'll use the same amount as it's travelling as it would when it's empty, and that's just not true. Same, if this car was going fast, it would use a lot more petrol than if it was going slow. Question 20, we've got 3 similar triangles, and similar means we've got perfect enlargements. So these triangles are so many times bigger than each other. Well, if we look at this one and this one, I think to go from 15 to 5, I'm dividing by 3, or timesing by 3 if you're coming the other way. So why am I doing that? Well, that would allow me to work out this side. Every side from this triangle to this one is dividing by 3. And 21 divided by 3 is 7. Why did I do that? Well, I'm looking to work out this side, and now I can go from this triangle to this one. And to get from 8 to 4, you're just dividing by 2. So I need to do the same on this side. 7 divided by 2. 7 divided by 2 is 3.5. Part B gives us some more triangles, and we've got one triangle inside of another one. The minute you've got this diagram, you've got the exact same thing that we just looked at in part A. You've got similar triangles. These triangles are perfect enlargements of each other. 2 separate triangles there. What we can look at is these sides compared to each other and see if we can find a relationship between those two. So what I'm going to do is do 14 divided by 4. Well, that's the same as 7 divided by 2. And we just did that up there. That's 3.5. So what we can say is this side is 3.5 times bigger than this side. And what I can do is apply that knowledge to this part of the diagram. And what that will tell me is this whole length. If I do 7 multiplied by 3.5, well, 3 sevens are 21, and 0.5 times 7 is just a half of 7, and we know that that's 3.5. You're going to get 24.5. Now that 24.5 is the whole bottom of this triangle, and what we're actually asked to work out is just BD. Now BD is the whole measurement, so 24.5. Take away this 14 that we were given. 24 take away 14 is 10. 24.5 take away 14 will be 10.5. Final question on this paper, we've got this love heart shape, which is actually 3 half circles. We're only told one measurement, which is from P to Q, is 4x. So from P to Q is 4x. And we're asked to work out the area of the whole shape. Looks complicated, but this is just circle work. So I'm going to start with this bottom semicircle. Let's draw that out. Now we know the whole way across this measurement is 4x, and the area of a circle is pi times the radius squared. This 4x is the diameter, not the radius. So my radius is actually 2x. I'm going to work out the area by doing pi times the radius is 2x. Don't forget to square that. And 2x squared is 4x squared. I'm going to times that by pi. 4x squared pi. If we look at these top circles together, well, they will actually join together to make a full circle. So I'm going to treat these two parts as one circle. Now I need the radius of this circle, which is from there to there. The whole measurement was 2x, so the radius of this circle is just x, or 1x. I can say the area equals pi times radius squared, which equals pi times x squared, which equals x squared pi, or x squared times pi. If we go back to my first semicircle, I didn't actually complete this question because this area works out the full circle, which is 4x squared pi. What I should have done is divide that by 2. 4x squared pi divided by 2 is 2x squared pi. If I now want to look at this full love heart shape, I need 2x squared pi added to x squared pi. Altogether, I've got 2 add 1, 3x squared pi, and 3x squared pi is the same as 3 pi x squared.